Hello, my name is Mark George and this is my Capstone project. My Capstone project is a computer-controlled helicopter. This is a quadcopter that I purchased. I installed an Arduino FIO microcontroller. I just taped it to the bottom. I'm using an XB radio to transmit data from it to the computer to another microcontroller. Underneath here I have an accelerometer, gyroscope. It's just wired to two of the inputs of the microcontroller and is powered from the microcontroller. This is powered through this USB cable right now. It's just plugged into this outlet because I don't have a coin battery to power this right now. That's something I want to work on. So I'm going to go through this pretty quickly to keep the video short. I have a lot of information to go through. So this XB radio is programmed as an end user radio. It's communicating the gyroscope data back to the radio over here on this Arduino Uno microcontroller. This radio is programmed as a coordinator radio, so this radio can communicate with any other radio that's within its range. The end user one can only communicate back to the coordinator radio. So this microcontroller here is basically just acting as a wireless USB. It's receiving any data from the radio and transmitting it up to the computer through the COM port through this USB. The other microcontroller I have is this Arduino Nano microcontroller. What it's doing is receiving serial data from the computer through this USB and sending information to this digital potentiometer. This is an EET402 digital potentiometer. There's actually 6 potentiometers on this chip. I'm using 4 of them. You can see here I removed, this is the original circuit board from the helicopter. I removed 4 manual potentiometers that you would move with your thumbs to fly the helicopter. This is just the battery pack that I'm using to power this circuit board from the original controller. I have 4 axes: forward, reverse, left and right, throttle up and down, and rotate, heading change. So those are the 4 potentiometers that I'm using from here. So each one of these microcontrollers has a program running on it, and I'll show you the programs next. The first program I'm going to show you is this Gyro Excel program. This is the program that's actually on the helicopter itself, on the microcontroller that's on the helicopter itself. This is kind of a borrowed program. I just downloaded this. You can get this from like the manufacturer's website. It's a generic way to communicate with the gyroscope accelerometer. So basically it just has a lot of serial prints. It's using some it's setting up a serial port. It's including some libraries here. There's that SPI serial peripheral interface, so we're probably using that communication method. So mainly we're taking the raw data, performing a little bit of math on it so that I can get a good heading, pitch, and roll numbers. Usable data. And so here are the numbers that are scrolling in right now from that program. And you can see I have a heading, pitch, and roll. Here's the raw data, which is not very usable. After the formulas in the program, I get good numbers. So anyhow, the next program that I have running is this. I called it Helicopter XB Coordinator because this is running on this Arduino Uno microcontroller, which is basically just a very simple program. It's set up in an XB. It's set up by a serial port at 9600 baud. All it's doing is reading if there is XB data available. If so, write that data to the serial port. So it's just reading from the radio and sending it to the serial port. Very simple. It's running at 9600 baud because the XBs need 9600 baud to communicate. It's given me a little bit of trouble with the accelerometer because it wants to communicate via 115/200 baud, but it seems to be working fairly well. So the other program that I have running on a microcontroller is this one here. It's a pretty simple program too. It sets up this SPI, this serial peripheral interface library too, because that's how that digital potentiometer communicates. Set up a serial port, 9600 baud. Here's a couple of variables, my throttle level, forward, left, right, that I created. And then I just have this switch case program here, real easy, that is just checking for values. So what I did was I used certain keys. I used a Q and an A for throttle up, throttle down. I used number 8, number 2 for forward, reverse, 4, 6 for left and right, and plus and minus for rotating, changing the heading of the helicopter. So all this is doing is checking the value that it reads in the serial and determines if it's an A, change the throttle level by 10. If it's a Q, change it in the other direction. 2, 8, 6, 4, plus minus. We're just changing the levels of each potentiometer. You can see the potentiometer number 3 is for the throttle. Potentiometer number 1 is for the forward. Potentiometer number 0 is for the left, right. Okay, so that's the program that's running on the Arduino Nano board. The only other program I have is this processing sketch, which is running on the PC here, and it's also a fairly simple program. It's just checking, setting up serial port, 9600 baud again, and it draws a window just because processing needs a window to be running. And so there's my window that's currently running. So this program is just checking if a key is pressed. If a key is equal to Q or A or any of the ones that I choose, send that key to the port, write it to the port so that this program will see it. It is also printing that key, in this case it would be a Q, down here, which is good for troubleshooting, so that whenever I hit a Q and my helicopter doesn't take off, I can actually see if I am in fact sending that Q to the serial port. And so that program just goes through all of my keys that I'm interested in, and that's it. Very, very simple program. So now I'm going to fly the helicopter. The first thing I have to do is make sure this window's open and click in it. What I will do is set up communication with the helicopter through the original controller first, which requires me to hit throttle up and throttle back all the way, and you'll hear this beep. So now I'm communicating with the helicopter through the original controller that came with it. So now as I hit different keys, I'm going to fly the helicopter. So here it goes. And so we can see, before we start, let's look at our heading, pitch and roll. The pitch and roll, I'll pick the helicopter up and manually move it to see those, because if you see those move, it's moving so much that it would be crashing anyhow. The heading, we're about at 7 right now. You can see the helicopter is facing in this direction. This cord's coming out the back of the helicopter. So our heading is about 7 degrees when it's pointed in that direction. I'm going to try to fly the helicopter a little bit here. I'm not very good at flying it, so we may crash a little bit, but let's see what happens. I'm going to change the heading. See how I rotated? We go back to 0. We're going to throttle back up. I'm going to rotate a little bit more. And now let's look at the heading. So the heading should have changed. It was at 7 degrees before. Now that we were rotated, my heading is at 71 degrees, negative 71 degrees. Okay, so I'm just going to pick up the helicopter, and you can watch me tip the helicopter. It's sitting pretty level. So my pitch and roll is pretty low numbers, +4, -2. So now watch, I'm going to change the pitch of the helicopter. I'm going to tip it to the left, and you should see the roll. See, we went to -61. Now if I roll the helicopter to the right, like this, roll it to the right, this number should go positive. As soon as there. See, now we're at 36. And now if I tip the helicopter forward, like this, you should see the pitch change to a more drastic number. Pitch, see, now we're at 44. And so you can see that my pitch and roll and heading are changing according to the accelerometer gyroscope that's on the helicopter. That's information that could be used in the future on the processing sketch. I can read this data in and change what is sent to the microcontroller according to this data, and that could help improve the stability of the helicopter. And that's my project. I hope you enjoyed it.